And then at the bottom is really the application that we have built on there now. We have a number of other pieces to it, a report if you actually want to go in and find a patient's LPR and look at it. So there's some utilities that go with it, but the basic thing then is the Clinical Hub application. In terms of expansions, if we think about, okay, one of the things that we always do if you're in this line is even before we've made the first one, we always think about what the second one might look like. And the expansion areas there really are in two directions. One is to maybe go to a larger set of sources of data to build out the patient model. We're not trying to be a data warehouse. We're not trying to be an EHR. We're trying to create this information so that it's searchable, usable, et cetera, within an operational context. But perhaps there's some more information available that I mentioned earlier, DICOM metadata, or perhaps image analysis. So that's one natural way of expanding it is to add these components that I can plug into Webster Message Broker. And then the other one is to say, okay, I've got a search application. Are there other applications or are there other uses of this that you would like to tie into? Is there information that you would like to put into a referral system, and so you would want to be able to query a clinical hub as part of a referral? So again, thinking about different applications and different APIs that go through it is probably the other way we would want to expand it. But this is the high-level architecture. Fundamentally, it's the master data service, the MDM solution we know and love, beefed up a bit in a few areas, as well as the data collection component, a data ingest component built upon WebSphere Message Broker that is using HL7 sources and applying this sort of text mining and de-identification to it, plus then the application layer, which allows people to get information to it. So that's sort of the bits that we're shipping as part of this. And that's it. This one I think I described earlier, but let me go spend 1 minute on this one. Is to say that when we take this information, an HL7 clinical message, we get that before we do anything with it. We go make sure we know the patient. We know it's MRN, and MRN gives us an EID. We take both of those pieces of information and we go back through it. And then we use the information that we have, the demographic information that we know about the patient, to de-identify the information within the rest of the HL7 clinical message. So I know the patient's name, and so I know if that patient's name is mentioned in a free text form, I need to anonymize that. And if I know, if date of birth we leave in here, but if there's other information that is part of the unstructured data or the structured data that is related to the identifiable information that we keep in the hub, in the EMPI, we anonymize that, we encrypt that. So we have encrypted identifiers. We don't have MRNs and EIDs or any of those other things. They're encrypted versions of that that allow us to tie back to the EMPI. And then we also use, as part of our de-identification process, the information that we have from the patient's HL7 message, but then also from the EMPI. So we anonymize names, et cetera. They get stuck into the HL7 messages in different places. So we are really working very hard to keep the information in this clinical hub as a limited data set. A limited data set, the key difference there from our point of view is that we like to keep exact dates of treatments. Birth dates we don't care as much about, but exact dates of treatments is key to being able to put together our longitudinal time series record. So this is a key piece to the technology, and we think that that's something that would be good for also supporting data warehouses and other applications. And really this is kind of the, if you want, the family jewels to the system, and that is how do I find similar patients? And the technique that we're using in this version, and as I mentioned at the beginning, there are multiple techniques. This is the one we think we will stick with, is a multimodal fusion, where we do some processing by similarities. We get that into a time history, so I can look at, I measure, I align the patient's time histories in a way so I can say, okay, are they doing things in the same sequence as part of the similarity? Because order is important in sort of treatments and drugs, et cetera, and results. So we use the time series to align these people, and then we fuse the information together once we've got that similarity. So that's a key piece to the puzzle. And sort of the last sort of architectural diagram is how does this fit really into the larger system? And so this, again, the clinical hub is really tied closely to the EMPI, and it's getting information from the service bus, and it's getting clinical information, ORUs, ORAMs, et cetera. Now, that can also be fed into a data warehouse and then combined with other information. So we see this as really sort of a separate piece from a data warehouse that's supporting operational instances that are, again, de-identified work, whereas the healthcare provider data warehouse, with Cognos or BI, whatever your favorite one is pulling in, non-HL7 messages that it's going. One of our products there, ICDA, is very good at going through file systems, file management systems, and pulling information out. And then financial systems, and then those are integrating those better in a data warehouse. We're really worried about the clinical information that's readily available from the HL7 messages. But obviously, the techniques that we use for doing the parsing of that information can feed either side. So I think I've summarized this, and I think left a few minutes for questions here. That really this has been a great, from my point of view, the perfect storm